Here's the first example. Good luck. All right, we'll do another one, and then you'll see what we did there with that one. Okay, next one. By the way, what's this a picture of? E equals 5. Again, what I didn't write up here is what you should be comparing it, but it was in our little thing up there for the 4 pictures. It reminded us of the 4 pictures of cosines are right and left, and then minus is actually right, plus is left. Signs are up and down, plus is sign down, minus for sign is up. Right, so this general form equation is what we're playing with this whole time. KE or EK over 1 plus or minus, we have to make a choice, and sine cosine of theta. And we have to know, which ones are which depending on the patterns that occur. So this is 5. Which way does this go? Like the important. Oh, by the way, what is it? What is it? I'm sorry. Hyperbola. Which way does it go? Okay, it's up, down, but it's up is the key component where I want to find some stuff. So here's the focus, and this is it's up, down with the other down part down there. And we'll actually prove that when we plug in some points because that's what we did in the first example that I did not video. Sorry, but some of it becomes redundant. Some people are already bored. Okay, so what values then do I plug in? That's the question. What values do I plug in? Pi over 2 and 3 pi over 2 because I know it's an up-downer. Instead of the last one, we knew it was short-wide. I wanted a major axis point, so I had to plug in 0 and pi. So r equals 12, just for note purposes. The next ones I won't. We'll just verbalize plugging in. Pi over 2. What side of pi over 2? 1 times 5. 5. 1 minus 5. Negative 4. 12 divided by that. Negative 3. So you get, I guess I'll write it right here, negative 3 comma pi over 2. How does that graph? Well, I go to pi over 2, but then which way do I go? Opposite direction. Now, is that the vertex for this part? I don't know yet. That seemed weird that it flipped over. Let me find the other one and then put it together how hyperbolas work. So r equals 12, 1 minus 5, sine 3. What's the sine of 3 pi over 2 as I... Negative 1 times 5. Negative 5 is 5. 1 plus 5 is 6. 12 divided by 6 is 2. So this gets me 2 comma 3 pi over 2. And that's not quite as far. So that is actually the vertex for this part. And then the other one is down here. Okay, so just for giggles, even though it doesn't ask you to do this, it does ask you A, B, C, and E. Really what you'd say, it's an up-down hyperbola. E equals this, A equals this, B equals this, C equals this, and then you stop. I'm still at the end going to find the equation rectangularly. So in the last example, we don't have to do. Because after you find all that information, it's easy. All right. So what's E? E is 5. Right? Isn't that what it says? Isn't that what we got? Okay. Because something strange occurs here. Like, how far is this? How far is this? 1. So what is A? 1/2. Right? What is C? Actually, what is C? 2, right? Isn't C 2? Correct? I thought I was screwing something up here. Huh? Let's pause this. I'm freaking out, man. I'm a maroon. C is how far away it is from the center. So what is that? Say it again. 2. I wasn't finished. 2.5. There we go. Now, what's 2.5 divided by a half, happily? What's 2.5 divided by a half? Okay, so it all shakes out. We're all good. I don't like 2.5. I like 3 halves. Okay, that's 5 halves. I wasn't finished. I had to put that little hook on the end. All right. Wow. Woo. Is it hot in here? All right. Now, what's C squared equal in a hyperbola? It's a hyperbola, right? I got that right? Hey, you're pulling your hair like that. Those girls in the second hour. You should be like them. All right. 5 halves, right, squared, because potentially making mistakes all over the place. 1/2 squared plus b squared. What's 5 halves squared? 25 fourths minus 1/4. 24 fourths is what? 6. So b is the square root of 6. I don't want to run into the next example. All right, but then I have actually all the information I need to actually find the rectangular coordinate plane version of the equation. X have any friends? X squared over. What's the x squared move right and left to create the box? I mean, what goes underneath x squared? It's actually 6. I'm writing this wrong. What should I do next? I should go left because what should I put in front of this? A minus. And then does y have any friends? What is the center even though I didn't write it? 2.5, so it's plus 2.5 because it's always y minus, right? Y minus the y value. Over, what's the y-axis move? Up and down, the y-axis radius. Squared. 1/4. Okay, now, I will say this. You get another teacher. I'm not sure what the other class is doing. I like this as standard form for this because then we know what the radius is. She may be forcing them because mathematically you should never leave a fraction within a fraction. Might have them leave it like this. Just be aware of that. I just like that for our class because we get the radii values shaken out of that. Equals what? 1. Okay? So that wasn't required for these set of directions. Here, I'll just go to it. Look at what this last one says. Determine a... Don't write it down because we're not doing it. By the way, what's Cartesian? Anyone know what that means? It's just an XY coordinate plane. I don't know if that's named after a person, Cartesius or something. Who knows? Okay, but that's what that means. So remember what we did back in the day, cross multiplied. What did I don't think we answered that question. What does R equal back in the old days? Square root of x squared. And then what was R cosine theta equal to? So then this would be square root of x squared plus y squared plus 2x equals 6. Then you had to complete the square and then complete the square and do all that. Or you can analyze the A, B, C, and E values and then plug them in. I don't know which way you'd find easier. Okay, now we got some weird questions. Oh, you bums that don't read directions. That's what I said, and it's on YouTube, and I don't care. It's not there yet. But I'm keeping it. Remember the elliptical bridge question? Okay, the bridge. And by the way, it's not, some of you are robots. You thought it was one of these questions, maybe. No, that's holding up the wires and stuff. The bridge has an elliptical opening. So, oh, by the way, if you did draw that, I drew an upside-down truck for you. I said, oh, is that how the truck goes? So, you know me. I hate him. All right? So, an elliptical bridge. So, what did it say? The bridge is elliptical. Why would you guys put a parabola for the formula in order to find the shape of the elliptical? You know what I'm saying? I really don't think you read the directions. So I'm just yelling at you to read it. What does it say this is? What does it say? An ellipse. And what does it say these points that are given are? The endpoints of the major axis. Okay, now just as a review, this is a review. What's the transverse axis? What does that pertain to? No, what's the transverse axis? Which drawing? Which drawing has a transverse axis? Hyperbola. Is the transverse axis the longest axis? Not necessarily. Is the major axis the longer axis? Yes. So these are things that we should know before, stuff that we did before spring break and all that, I believe. But anyway, which way does this ellipse go? Or better said, is this tall, skinny, or short and wide? Look at the coordinates. It's tall, skinny because these are the major axis points. You'd only know that if you actually read. That was, I don't know what you just said there. Pi over 2 comma 1 is right here. Pi over 2, or 3 pi over 2 comma 3 is right here. Okay, so which way does this really go My question meaning, which of these four pictures is it? Is it going up or down? Down. Okay, that's the key component where the directrix is up here. Okay, we do have an issue. It's kind of a big issue. I mean, from this information, I can find things right off the bat. What does it ask me to do, too? Find the polar equation. Okay. All right, so we do got some information. Like, what's this? What's this? That's the length of the major axis. Actually, I'm thinking of rectangularly. I got to think this is what I have to fill in. KE over 1 plus or minus sine cosine theta. So is it plus or minus, knowing that it's going down like this? So it's plus. Let's start filling in the parts as we get it. What is it sine or cosine? Sine. Oh, I need a space for E. Oh, I forgot E. I did that second hour too. E, sine, cosine. So I'm not putting anything for E yet. It's sine of theta. So we're getting our parts. Oh, it's 1. Ooh, I'm excited. Okay. Now, let's see what we got to do here. All right, we got to stop. I got to think for a second. I'm freezing. Go time. Okay, so now thinking rectangularly, when I see this picture, I know this is a what, by the way? What is this right here? It's a focus. That's how these are made. The focus is at the pole, which is the blank origin of the rectangular coordinate plane. Anyway, nice little vocab word. So E comes from C over A, and I have those two numbers. What's C? 1. What's A? 2. So now E can go here and here, and then I have this equation now. Now what could I do? Plug in a coordinate. Does it matter which one I plug in? It shouldn't, and it won't. So now I'm going to plug in 1 equals k 1/2 1 plus 1/2 sine pi over 2. What's sine pi over 2, everybody?
1.
Okay, so show this over here. What's 1 times a half? Half plus 1? 3 halves. So I get 1 equals 1/2 k over 3 halves. Cancel the 2's. 1/3 k equals 1. What's k equal? 3. Now it said find the polar equation. So now I can fill in those final parts. 3 times a half. So r equals 3 halves. Over 1 plus 1/2 sine theta. Or a teacher that is angry might mark you wrong because there's fractions within fractions. So r equals 3, 2 plus sine theta would probably be the cleanest version of that. See? It's not so bad. I'm talking to myself because I was freaking out when I had to do these notes. Read the directions. This is a what? Hyperbola. And then what is this? Points of the transverse axis. Which way is this hyperbola going? Up, down, or right, left? Okay, right, left. Now this is strange. Just put this here. How do I graph -3, 0? It's supposed to go 0, but then go left 3. And rectangularly, it would be the same thing, oddly enough. But 1.5 comma pi doesn't graph rectangularly. You do pi. Oh, strange. 1.5. How weird is that? Oh. Okay, so again, for a hyperbola, this is going right, left, and this is the right part. And this is the left part. But it's the one that's going right is the one I care about. So r equals KE, let's just fill in. What do we have? 1 plus or minus? Minus, and then cosine E, gosh dog it, theta. Okay. All right. Oh, my shoulder. What's this number? All the way from each of the endpoints. How far is it? How far is it, though? What is the number that represents how far they are away? Oh, okay, what is that called? That is the length of the transverse axis. So what is a half of that, which is what? 0.75 or 3/4. What's this number represent? C, what is that number? Which is 3/2. What's E? C over A. Again, the 3's cancel. What's 1/2 divided by 1/4? 2. So E is 2. And now we could do the same thing we just did in the last one. I don't care which one you plug in. Let's get crazy and plug in the -3. Equals 2k over 1 minus 2, the thing I keep trying to forget, cosine 0. What's cosine of 0? What's 1 times 2? 1 minus 2 is, so 2k over -1 equals -3. What's k equal to? 3 over 2. And then you go back, I wish I had spaced this out better, and put it all together. So r equals, all right, 3/2 times 2, which is nice, so I don't really have to do anything. What's 3/2 times 2? 3 over 1 minus 2 cosine theta. Because that's all I was trying to find was what's that k value, and then plug it in. Did I skip one? I did! Oh no, oh yeah. Okay, let's go back to this one. And this is why I'm not doing this last one, because, after I find all that information, a Cartesian equation, you can do everything I just did, or you could do what you did before break and cross multiply r equals the square root of x squared plus y. I don't care. I really don't. Okay, now, but let's go back to this one, because this one's unique. I knew I forgot one. Graph the conic. By the way, what's this a picture of? Parabola. Which way is it going? Someone said diagonally. It goes like this. What is? All right. Actually, that is a section. 8.4 is rotating these and then going diagonal. Yeah, they're not fun. I kind of read through it. Okay, divide by 3 though, right? Wouldn't that be smart? Now, I just wanted to cover this because, how do you graph it just with this here? Plug in points. And then something happened that weird that I analyzed, and we analyzed in the other hour. And actually, I analyze it after second hour because I'm a dork. That's what I do when I'm doing lunch. 0. What's cosine of 0? 1 plus 1. 4 divided by 2. So going to a coordinate plane, this is what we get. 1, 2. And then from this, I can find the rectangular equation, which is one of your questions. You have a picture of a parabola, and then it asks you to find the rectangular equation or the polar equation. One or the other. You should be able to do both. Okay, next. Pi over 2. What's cosine of pi over 2? 0 plus 1. 4 divided 4. 1, 2, 3, 4. Kind of shaken out already, right? This is where it gets weird. And then I'm going to explain this. We're actually going to overanalyze this because we're smart people and we like to know the math behind the scenes. What's cosine of pi? -1 plus 1. Ah! 0. What's 4 over 0? Undies. What is happening? So I don't have a pi comma point? It's actually very simple. And then we're going to go to the calculator. What's pi approximately? 3.14. But what happens when I take the cosine of 3.14? Will I get 0? No. See, you'll get the angle measure that's right close. That's what we're going to do on the calculator. And I'll analyze why this is undefined, but then why before it's not. And we're going to analyze it through what's happening with the parabola. Let's keep going. Oh, I can tell the excitement. You should see all the kids' faces. You're like, ooh, I can't wait. Cosine of 3 pi over 4, or 3 pi over 2. 0 plus 4. 1, 2, 3, 4. All right, and then 2 pi, you just end up with 2 again. So, okay, so this is the parabola, and it goes like this. So why did I get undefined at pi? Well, I think you could already see pi comma, I mean that's on this axis where these points are going like this, right? So you get why pi is undefined. Actually, I didn't get this morning. How is that undefined? What's going on? And then I thought, okay, well let's I'm so excited I can't even talk. Let's plug in 4. Put your calculator in radians, or I got it. You do nothing. That's usually what happens. Divided by what? 1 plus cosine 3.14. Is that pi? No. It's right before pi. It's the angle measure that's like right there's pi. There's 3 point. If I this is 3 point. This is, they don't get it. I can see how I just barely missed. He get it. All right. Enter. Look at that. What's that number? 3,153,000. So at this angle measure, comma 3,000,000. That point's way out there, and lo and behold, that's where the parabola hits it. You get it? Then I went further nuts, and I thought, hey, what's that coordinate rectangularly? So what I did is I created a triangle, and I got the x comma y values just to see how far out this goes. The x values you could surmise is very close to, it's 3,000,000, then just a shade under 896, comma, the y value was like 5,000. Actually, it was negative 3 million, comma, like 5,000 up. So I just thought I would share that. So it's a parabola. Okay, so what's the equation? What's the equation rectangularly then? What's this number? They all fell asleep after that glorious... So what's the equation? Is it an x squared or a y squared? Y squared. Oh, and does y have no friends, Mr. Samuels? Equals, what's p? It's 2, but what does that mean goes in front of -8? And then does x have friends? Yes? X minus 2. So from that graph, you could actually come up with the rectangular equation immediately. How to get the polar graph, you got to do the other stuff. Okay? All right, now I'm done. So over explanation yet again for Mr. S.